Let's start with 27 through 30, the homework assignments. If you would, please. So, 27 says a mass on a spring oscillates back and forth and completes one cycle in 0.25 seconds. Its maximum displacement is 4 centimeters. Write an equation to model this motion. So the picture that we're going to think about here is I have like a spring with a weight on the end of it. And we're going to pull that weight down and then let it go, and it's going to bounce up and down kind of like this. Everybody okay with that idea? That's the situation that's being described here? Okay. So, because we're dealing with something that has maximums and minimums, my suspicion is that the easiest situation to deal with is a cosine. So I'm going to write a cosine function. So, it says here the one cycle is 0.25 seconds. What does one cycle mean? 1 period equals 1/4. So I know 2 pi c is equal to 1/4. So I know absolute value c is 1/8 pi. And as we've typically done, we're always going to pick c to be positive. Everybody okay with that? So when we say displacement, we write here the maximum displacement is 4 centimeters. What that's really talking about is the amplitude. You're correct. So if this is like the midline, we're saying this would be like my 4 centimeters is this displacement. So that's absolutely correct in that the amplitude is 4. Now, because this is just moving up and down, can we say anything about a h? No. Because we're not told whether like we drop it from its maximum or we pulled it down and let it go at the minimum. Can we say anything about the sine of a? Not really. So we're free to pick either one of those. I think you'd be silly to pick h to be anything other than 0 and the sine of a to be anything other than positive. And similarly with k. Again, this would be the value for k. We're just going to assume this is at like a 0 displacement. So literally all I'm going to write is 4 cosine of 8 pi. I guess we've been using h's and t's when we did this. So I'll say h equals 4 cosine 8 pi t. Um, 28. Oops. So it says that a Ferris wheel has a diameter of 90 feet and the center is positioned 50 feet off the ground. So I know this distance here is 50. Everybody good with that? How far is this distance here? 45, because it's half the diameter, which means that this little spot here is got to be 5 feet. Everybody agree with that picture we've drawn here? Okay? So, I know right away that my k value is going through the center here. So I know the k is 50. I know that the amplitude is the distance from the midline to the extrema. So I know the radius is my amplitude. All that I'm left with now is to figure out my value for h and for c. To figure out the value for c, what information am I going to use? 1 revolution is equal to 84 seconds. Note that I want to write my function in terms of t seconds, so I know that just 1 period is going to equal 84. So 2 pi c is going to equal 84. So the absolute value of c is going to be 42 over pi. Everybody happy with that? Good. And the last thing I know is that to figure out h, I'm going to use that the rider gets on the lowest position possible. What is that telling me? Yeah. It's starting at a minimum. So that tells me the a value should be negative. So putting this all together, I have negative 45 cosine of pi over 42 x minus 0 plus 50. No, you do not need the minus 0. You could just simplify it down. I just chose to put it in there so everybody sees that the h is 0. Good for you. All right, the next one is another Ferris wheel problem. Oh my God, come on. It says that the Ferris wheel is 120 diameter. So I don't care so much about the diameter. What I'm more interested in is the radius. And we know that it's 15 feet off the ground, or 15 meters off the ground, excuse me. All right. So what is my value for the amplitude? That's the radius. What's my value for k? 75. It's the height of the center of the Ferris wheel, right? Okay. So we've gone and gotten those two just from drawing our picture and interpreting that. Next, we'll figure out c. To figure out c, I'm going to use the 1 revolution is 30 minutes, so I know 1 period is 30 minutes. And I know a period is 2 pi c. If I divide both sides by 2 pi, I get that c is 15 over pi. Next thing I need to do is determine whether I should be using sine or cosine, and then to figure out the value for h. So, should I use sine or cosine here? Cosine, good. And do we know where the rider is entering? Yeah, I think that we're supposed to assume they're getting on at the lowest point. So my a is negative, and my h is 0. So putting this all together, I have negative 60 cosine of 15 pi, pi over 15, x minus 0 plus 75. Everybody okay with that? Okay. Assuming we get on at the lowest point, what will the height be after 17 minutes? To figure out this, what do we have to do? We're just plugging in 17 for t. The one thing I have to make sure is that this unit is in minutes. What is my unit for t in my function? I used minutes to calculate the period, so all the units should match up there. So,
I have a lot of trouble trying to plug things into my calculator. Could you pull up the calculator and maybe something?
absolutely. You're welcome. So, I'll do negative 60 times cosine of pi divided by 15 times 17, close parentheses, plus 75. And I get 129.81. If you're getting an unreasonable answer and you think you've plugged in things correctly, what's the most likely problem? Wrong mode is the correct answer there. It's very possible you're still in degree mode if you think you're plugging this in correctly and you're getting something that looks like a nonsense answer. That would be the first thing that I would check. So, are you good with that?
Yeah.
Okay. It says for C, once Lee exits the eye, he notices his friend is currently 80 meters off the ground. How long might his friend have been on the eye? So to solve this, I'm just going to plug 80 in for my value for H and solve for T. So to do this, I'm going to start by subtracting 75 from both sides. I'm going to start writing it down off to the side here. And then divide both sides by 60. Obviously, you don't need to write that as a fraction. A decimal is fine. To get rid of the cosine, we take the cosine inverse of both sides. And then I'm going to multiply by the reciprocal. And then it's calculator time. So I do 15 divided by pi, divided by pi times cosine inverse, negative 1 divided by 12. So when I do that, I can say t is about 7.9 minutes. Stop talking, please. Is this the only acceptable answer? No, right? If we go back to here, we could have two locations that are both 80 degree or 80 feet off the ground. Or you could have something coterminal to that. I'm not going to worry so much about what those other solutions are right now. We will talk in depth about what those other solutions are and how to find them a little bit later when we talk about solving trigonometric equations. I just want to point out that there are more than one solution to this. But since we ask the might question, I only care about one. If you can find one of them, that's fine. The one that we found is the easiest one to find. That's what I would recommend you guys doing each time. Okay, last one. We have Domingo is a surfer in Maui. He checks the tidal charts on June 29th, 2013, and we find that high tide occurs at 8:12 a.m. When I see the word high tide, what am I thinking? Okay, and we have low tide at 2:18, so that's a minimum. Write an equation to model the depth of the water on this day. So, I know that high tide And low tide is basically my y max and my y min. So to find k, I can do y max plus y min divided by 2. So that's 5.4 plus 2.6 divided by 2. That gives me 4. Similarly, I can calculate the amplitude by doing y max minus y min divided by 2. When I do that, I get 1.4. See you later. Good luck with your tennis. Oh. Good luck with other things. Okay. So, that is my A and my K. Any questions with how I did that? That's very much like we've done in the past, right? No big issues there. Just using our formulas. Are there other ways you could have done that? Yeah, you could have drawn a picture and done all kinds of things. That's, I think, is the easiest way to do it, though. What I'm going to do now is I'm going to look for the period. So I have high tide over here, and then low tide over here or something. That is half a period. Everybody agree with that? So I know that 1/2 a period is going to be the difference in time from 8:12 a.m. to 2:18 p.m. What is that? So we need 48 minutes to get to 9 a.m. And then I need 3 hours to get to noon. And then I need 2 hours to get to 2. And then I need another 18 minutes. So 18 minutes plus 48 minutes is 1 hour and 6 minutes. So if I count that up, that's 3, 5, 6 hours and 6 minutes. But it's pretty stupid to write that as hours and minutes, right? Let's just convert that all to one or the other. I'm going to convert it all into hours, I think seems to make the most sense. So 6 minutes is 1/10 of an hour, right? 6 divided by 60 is 0.1. So I'm just going to call this 6.1. So I know that one period then is 12.2, which is equal to 2 pi c. When I divide both sides, I get that the absolute value of c is 6.1 divided by pi. Everybody okay with that? All right. Next up is to figure out my value for h. So I'm going to be starting with a maximum. So the x-coordinate for that maximum is just going to be my value for h. So h is going to be 8:12 a.m. I need to convert that into hours, though. So that's going to be 8 hours and 12 minutes. 12 divided by 60 is 1/5. So that's going to be 0.2. So h is 8.2. So I can say y equals 1.4 cosine of pi over 6.1 x minus 8.2 plus 4. Okay with that idea? Okay. Find the depth of the water at noon. Well, I guess I probably should call these H's and T's. Noon. What value for T should I put in for noon? 12. Because it's 12 hours. If 8 a.m. is 8.2, 8 hours and 12 minutes is 8.2, noon has to be 12, right? So I'll just type that in. When I do that, I get about 3.47. Did I type that all in right? Okay. So 3.47 meters. Okay. The last question asks, when will the high tide occur on June 20th? So on June is what? Is that the 6th month? Okay, 6/19. We have a high tide at 8:12 a.m. Everybody agree with that? 1 period later, we should be at high tide again. 1 period is 12 hours and 12 minutes. So that would be at 8:24 p.m. That's still on 6/19 though. So I need to do 1 period more to get to another high tide. 1 period more would be 8:36 a.m. That's now on the next day. So that should be that. It's not the answer I had written down in the key. Why not? Did I do this subtraction wrong? Did I count 606 wrong? No? All right, I think the key is just wrong then. I don't know. It's good enough. You guys get the idea though, right? No? What are you confused about, Joanna? Okay, so all I'm doing is just counting periods because it's asking when the next high tide will be on that day. So I know high tide to high tide is going to be 1 period later. Agreed with that? So I know half of a period is 6 hours and 6 minutes. So 2 periods is going to be 12 hours and 12 minutes. And basically I'm just adding 12 hours and 12 minutes to the time and seeing what day that would need to be in. So if I start at 8 a.m. with my first high tide, if I add 12 hours and 12 minutes, I'm at 8:24 p.m. But that would still be on the same day. So I need to do it again. Gives me 8:36 the next day. That would be the time on the next day. Does that make sense now? Basically, I'm just keep adding periods till I'm on the correct day. So you just have to add time, which is inconvenient because adding time is weird. Because it's not base 10. We should go to metric time. 10 hours a day, 100 minutes to an hour, 100 seconds to a minute, 10 days to a week, 100 weeks to a year, metric time. I'm pitching it right now. No? Nobody likes that idea? All right. Review. Do you guys have questions from the review?
I have a question.
Sure.
Well, it's not even a problem, it's just a question. So, everything we just went over, none of those problems are on this study guide?
Correct. They are on the list of topics that I posted to Power School attached to the test. So there is one harmonic motion question.
Is it going to be a Ferris wheel?
Probably.
Okay. You can make it the one that I make it small. The problem with the whole space. Okay.
We could make some really fun harmonic motion questions if you really wanted to.
Could you specifically show how to graph it? Because I struggle in the graphing portion of graphing.
So if you didn't, I put an stop talking please. I put an announcement up about that I forgot to update this because we took out some topic, and so I had depending on when you looked at this, these section 3.2 or question 6 might have been changed. So I changed these because they had a bunch of secant and cosecants, and we haven't talked at all about those, and we're not going to talk about graphing those things this year. So I just changed it to tangent things. Is there one of these that you'd like to do, Olivia? I just want to make sure I pointed that out in case somebody's looking at this and going, it's not the ones I have.
Maybe B of question 7.
B on question 7. Okay. So first thing I'm going to do is determine my values for A, C, H, and K. To do that, I'm going to have to write this in a factored form. So A is 1, C is 2, H is pi, and K is 2. Happy with that, Olivia? Okay. So I'm going to use that to write my transformation map, which is Cx plus H, Ay plus K. I'm now going to use my reference points. Stop talking, please. For tangent. So, okay, so let's talk about how to find them. Does that sound okay?
That sounds really good.
Okay. All right. So stop talking, please. So these are the x values that I'm concerned. Yes, of course. Those are the x values I'm concerned about for tangent. So I'm going to go to my unit circle and find negative pi over 2. Negative pi over 2 is here because I'm going in the negative direction. I go counterclockwise. And then tangent at negative pi over 2 is opposite over over adjacent, which is the same as sine over cosine, which in the unit circle is negative 1, the y-coordinate, divided by 0, the x-coordinate. Anything divided by 0 is undefined. If I go to negative pi over 4, that's here. So if I do that, y divided by x is negative 1. If I go to 0, that's here. Y divided by x is 0. So that's how I'm coming up with the y coordinates.
Okay.
Does that make sense?
Yes.
Okay. I'm not convinced, but I'm going to let it go. All right. So what I'm going to do now is I'm going to just push these through. So negative pi over 2 times 2 is negative pi, plus pi is 0. Anything done to undefined stays undefined. Negative pi over 4 times 2 is negative pi over 2, plus pi is positive pi over 2. Negative 1 times 1 is negative 1, plus 2 is 1. 0 times 2 is 0, plus pi is pi. 0 times 1 is 0, plus 2 is 2. Pi over 4 times 2 is pi over 2, plus pi is 3 pi over 2. 1 times 1 is 1, plus 2 is 3. I don't know why I wrote a plus 1 there. That doesn't need to be there. And for the last one, pi over 2 times 2 is pi, plus pi more is 2 pi. Undefined. Anything you do to undefined stays undefined. Okay? So I'm going to go to my graph here. So first thing I'm going to do is find x equals 0 and write in my asymptote. At pi over 2, I'm going to plot the point 1. At pi, I'm going to plot 2. At 3 pi over 2, I'm going to plot 3. And at 2 pi, well, if I look at this, this is pi, this is 0. Halfway in has to be half a pi, right? So they're going up by half a pi, so 0, half a pi, 1 pi, 1.5 pi, 2 pi, 2.5, 3, 3.5, 4. So I'm just counting. So 3.5 is the same as 1.5, right? Does that make sense? Okay, so now I'm going to connect these. So I'm going to follow the asymptotes, go through my points, and then follow the asymptote. So now to fill this space, I need to start first with this point. So that point would go here. Then I need this point, which should go here. And then last, I'm going to need this point, which should go here. And then I'm going to have my asymptote. So I'll follow the asymptote, go through my points. And then I have one little area over here at the end to fill in. So all I can put in is one point there. It would be this one up there. So I'll just do that to kind of fill in that little spot. Does that feel okay, Olivia? Okay. So again, to fill the spaces, I'm just copying the pattern that I established in the first period. And again, to plot the points, I'm just trying to think about them without the pi's, just thinking about them as fractions. So like pi over 2, I'm just going to think about as a half. So, like half would be right here. That's all. So again, trying to keep it as simple as I can. You know what I mean? What else would you like to do, Joanna? What page is it on? Page 4. So this one? Okay. So I see here that A is 2, C is 1, H is negative pi, and K is 0. Any problems with that? Good. So the map I'm going to draw is CX plus H, AY plus K. So I'm not going to draw in the right in the ones and zeros. The key points for cosine, 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and then 2 pi positive 1. So, applying my transformation, then I have negative pi, comma 2. I have negative pi over 2, comma 0. I'm going to have 0, comma negative 2. I'm going to have pi over 2, comma 0. And I'm going to have pi, comma 2. So this guy, I notice, isn't exactly on my graph. That's okay. I'm just going to skip drawing him. So negative pi over 2, 0 is the first point I can draw, which is here. And then I have 0, negative 2. And then I have pi over 2, 0. And then I have pi, 2. And then I'm just going to kind of continue my pattern. Yeah, I would just skip drawing it. I mean, if you extended your graph to, like, put it on there, it's not like it's wrong. Well, they shouldn't. Okay. So, if you do this, I'm not okay with that. If it attempts to be curvy, I'm going to probably give you the benefit of the doubt. Okay. I try not to, for a skill that I am not good at, which is neatness and like art, I'm going to try not to be too hard on anyone else. If you have the points down there and the points are in the right place and things are reasonably connected and it's like, like you drew it as reasonably. I mean, if it looks like this or something, I'm probably going to have issue with that, where it looks like you had kind of a stroke while you're drawing it. That's an issue for me. Like, there it's curvy, but like they're not straight enough. So like there's a... Who's afraid of that ghost? All right. Math busters. All right. No, that's a ghost.
Accurate representation of a
All right. Shh. Can we try to refocus here just a little bit? Refocus a little bit. Who's next? Other questions from review? Okay. I'm happy to do some more.
Alright, let me find one. Let's do, I don't know what page it is. Section 0, 3.0, continued. Construct a sinusoid with the following property. Sine. Let's do D.
Is it this set of problems? So I'm going to draw myself a picture to kind of help myself see what's going on. So 7, 2 could be, say, here. 15, negative 13 is there. Everybody agree with that? So we're told that this is a midpoint. And I know that this one then is a minimum, right? Because it's below the midpoint. So right away, oops. I know where the midline is. The midline is at y equals 2, which tells me immediately that k is 2. Okay with that, Olivia? Okay. If I were to extend this graph one full period would look like that. Do you agree with that? Okay. So how much of a period are we at when we're just between the midpoint and that minimum? Is that a quarter? That looks like a quarter to me. So I know a quarter period then is going to be the difference in the x's. Looking at a picture is the best way, by far. Yeah. Not really. To be honest with you, there's not a good way without essentially being the same thing as drawing the picture. So I would say midpoint to any extreme as a quarter. So how many of those sections you have. So like that's another quarter. You know, like this would be another quarter. And then like that would be another quarter. So if you're going midpoint to extreme or extreme to midpoint, those are all quarters of a period. If that helps at all. So if you're going max to min, you have to pass a midpoint in there. So it's 2 quarters or a half. So same idea. Anyway, so the period is 32, which has to equal 2 pi c, which is going to be 16 over pi is for my value for c. To find the amplitude, do you want to do it the hard way or the easy way? Easy. So the amplitude is just the distance from the midline to an extrema, right? So how far is that? It's 15, right? We're starting at 2 and going down to negative 13. That's 15 units we did. Definitely. Yeah, it definitely helps to be a visual person. Yeah. If you okay. Is everybody happy to hear? So I just looked at the difference in the x-coordinates, 15 and 7. All right, so the only thing left to do is to figure out the h and the sine for a. So to do that, I need to pick a trig function to use. Would you like to use sine or cosine here? Okay, we can use sine. If we're using sine, which point am I going to be concerned with? Good, that's correct. So if I'm graphing the parent function, sine of x has a midline point at 0, 0. Now I need a little bit more information than that, though. So if I think about the graph of sine, this is the parent function, what it looks like. So before the midline point, the graph is below the midline, so I'm going to write a down arrow. And after that midline point, please stop talking. The graph is above the midline point, so I'm going to put an arrow after it to designate that. Okay with that idea? Okay. Now I'm going to sketch some information about my transformed function. So again, here we have a midline point at 7, 2. Here's our midline point. Where's my graph relative to the midline prior to that? Is it above the midline or below? It's above, right? It's over here. And then it's below after. Notice here what is going on. Those are opposite of what we'd expect, right? That tells me that the a needs to be negative. Yep. Is that there's a reflection going on. And then to go from parent function to transform function, I know I can do I can take this x and turn it into that x by doing cx plus h. So c times 0 plus h should give me 7, where I get h is 7. So now all I need to do is put all this stuff together to say y equals negative 15 sine of pi over 16 x minus 7 plus, what did we say k was? 2. That's one acceptable answer. You could have also done this using cosine, and you could have gotten an answer that way as well. But I just did what you guys had asked me to, so there's no problem doing it this way. To do it using cosine was no more difficult. The thing you have to be careful about when you're using sine, though, is that midline point thing that we did over there, where you have to make sure that there's the value for a is correct by looking at the architecture surrounding that midline point. Does that help? Good. It was more reassuring than last time. Good. I'm happy to. What do you want to look at next? What's next, guys? Yeah, we'll just keep going. You can ask as many as you want. Joanna. One harmonic motion question, right? So, again, if we looked at the test assignment on our Power School page, I posted a list of topics that we're going to be tested on. So the number in front tells you the number of those kind of questions. So like one question where I just ask you to describe the transformation. Do the 1, 2, 3, 4, 5, 6. 2 questions where we write the sinusoid from the given information, just like the one that we just got done doing. One question where we write the sinusoid from a graph. We did that in the homework. We had a worksheet doing that. One question where we write the tangent function from the graph. We did that in the homework. 2 graphing problems and 1 harmonic motion problem. I think there's 9 total, maybe. 8, okay. Some of them have a lot to do, though, right? Like if you're graphing something, you have to do a lot, right? You have to find all the points, you find the amplitudes and the periods and all that jazz. Like, it takes a minute to do all those. Yeah, a lot of involved problems. I can't put a ton on there. And I wrote it for a 50-minute class period. So, I go by that with my friends. Not you guys. I'm not going to get into that right now because it's being recorded. Joanna. Yeah, it's a sense. Yeah, it's nothing tremendously different. We're still just using a lot of the visual tools to shortcut through some of those things. But it's the same idea. But the big difference being that the the period is pi rather than 2 pi. Yes, correct. Yeah, go ahead, Joanna. Yeah, those are the 3 types we talked about. We didn't do anything with cosecant or secant or cotangent. We're not going to worry about those graphs in this course anymore. Olivia.
Do you do I for question 4? Like the list amplitude and period and frequency?
Which section? What page number? Is this it? This one right here? This one? Okay. All right. So what I'm going to do is I'm going to start by writing this in a factored form. So when I factor 6 out of 4, what do I get? 2/3. So I know that A is 1/2, C is the reciprocal of 6, H is 2/3, and K is -12. So my amplitude then is the absolute value of it, 1/2. My midline is y equals k. My period is 2 pi times the absolute value of c. That simplifies down to pi over 3. And the frequency is the reciprocal of pi over of the period, so 3 over pi. 2 pi times the absolute value of c, which is 1/6. And that simplifies down to just pi over 3. So the trickiest part was making sure you got that factoring part right in the beginning. So how did we get the 2/3 again? 4 divided by 6, whatever you factored out. Who's next? Sure. Doing the same thing, so y equals -3 times sine of -6 pi x minus 0 plus 3. So a is -3. C is 1 over, or -1 over 6 pi. H is 0. K is 3. So my amplitude here is the absolute value of -3. My midline point is y equals 3. my period is 2 pi times the absolute value of negative 1/6 pi, or negative 1 over 6 pi, I guess I should probably read that as. When I simplify that down, I just get 1/3. And then my frequency is the reciprocal of the period, so that's 3. Does that feel okay, Olivia? Okay. Oh, sure. And I posted the key for this, right? Did you guys see that? Even after I updated the questions, I reposted a key with the updated answers in it. So that should be okay. Any last things from you guys? No, there's no homework.